What if you could send a video to Telegram, let N8N process it automatically with FFmpeg, and receive a much smaller version back a few seconds later? That is exactly what we are building today. I will send this video to my Telegram bot. N8N will download it, save it temporarily on the server, pass it to FFmpeg, compress it, send the processed version back to me, and then automatically clean up the temporary files. And here's the result. The original video is about 8.9 megabytes. The processed version is only about 1.5 megabytes. And the resolution is still the same. This simple workflow will also become the foundation for the more interesting things we are going to build later in this series. So let us build it from scratch. Before we begin, this tutorial assumes that FFmpeg is already available inside your N8N container. If you have not watched my previous video where we installed FFmpeg and FFprobe inside N8N Docker, click the I button above and watch that tutorial first. That video prepares the exact environment we are using today. If FFmpeg is already working inside your N8N container, you are ready to continue. Before we start adding nodes, I am going to give this workflow a simple name. I will call it Telegram Bot. This will make it easier to identify later as we continue adding more video processing features. Our first node is the Telegram trigger. Think of this node as the doorbell. Nothing happens until somebody sends something to our bot. Add the Telegram trigger and choose On Message. We use On Message because Telegram sends videos as part of a normal message update. Next, we need to connect this node to a Telegram bot. I have already completed this part on my setup, but let me quickly show you how easy it is to create your own bot. We will do this directly inside Telegram. Open Telegram and go to the search box. Search for BotFather. Then select the official BotFather bot. BotFather is Telegram's own tool for creating and managing Telegram bots. I have created bots here before, so you can see some previous options and commands in my chat. If this is your first time using BotFather, your chat may look much cleaner than mine. That is completely fine. I will copy the Create a New Bot command and send it to BotFather. BotFather now asks us to choose a name for the bot. This is the name people will see when they interact with it. You can choose any name you like. For this tutorial, I am going to call mine my YouTube Testing Bot. Next, BotFather asks us to choose a unique username. The username must be available, so if the first name you try is already taken, just try another one. I will quickly choose a username for this test bot. And there we go. Our Telegram bot has been created. That was the entire setup. BotFather now gives us the token that allows another application, such as N8N, to communicate with this bot. Copy this token and keep it private because anyone with this token could control your bot. Now go back to the Telegram trigger node in N8N, create a new Telegram credential, and paste the bot token into the credential field. Then click Save. Once the credential is saved, our Telegram bot is connected to N8N. Now let us test the connection. Click Execute Step. At this point, N8N is waiting for something to arrive from Telegram, so let us give it something to work with. I will open the chat with my new bot. Then, I will drag a small sample video into the Telegram chat and send it. As soon as the message reaches the bot, our Telegram trigger receives the update. And you can see that the node has successfully captured information about the video. Now we'll pin this node so we can reuse its data again and again. We have not yet downloaded the actual video file. That is the job of our second node. For node number 2, add another Telegram node. This time, choose Get a File. We also need to connect this node using the same Telegram app credential that we connected to our first node. The first node gave us the video file ID. Here, we can simply drag and drop the video file ID from the previous node into this field. This simply means take the file ID from whatever video triggered this workflow, so every new video can be handled automatically. Make sure downloading is enabled. Now, execute the node. Execute the node and switch between the JSON and binary output. Preview the downloaded video. If you open the binary output, you should even be able to preview the video. We'll pin this node as well. Now we need to save it somewhere. FFmpeg can work with it. Add the read/write files from disk node. Choose Write File to Disk. Now, in the File Path and Name option, we'll enter the path to our Docker shared folder. FFmpeg works much more naturally with an actual file path. To do that, click the Expression option and then click this arrow icon. A pop-up window will open. Paste this expression there. Look carefully at the file name. Instead of simply saving every video as input.mp4, we include the Telegram chat ID and message ID. To do that, we will add a custom expression inside the File Path and Name section. This creates a file name similar to "Why are we doing this?" Imagine two users sending videos close together. If every video were called input.mp4, one file could replace another. A unique file name keeps each request separate. For the binary input field, use data now, execute the node. Now FFmpeg finally has something it can process. Our next node is where the interesting part begins. We need the execute command node because this is what allows N8N to run FFmpeg. Now, if you are using a recent N8N2.x installation, you may notice that execute command does not appear in the node list. That is intentional. Recent N8N versions disable certain powerful nodes by default. We can enable it through our Docker Compose configuration. Inside the Docker Compose environment section, I added these variables. After recreating the N8N containers, the execute command node becomes available. I have already prepared the Docker Compose file used in this tutorial. You can find it on my Oldie Tech blog, and I have placed the link in the video description. I have also included the required file access configuration there, so if you use that Compose setup, you should not need to stop halfway through the tutorial fixing folder permission settings. The idea here is simple. I want this video to focus on building the automation, not on making you copy long configuration files from the screen. And one more thing before we continue. You do not need to manually type every long command you see in this tutorial. I will also share the link to this workflow in the video description. So focus on understanding why each node exists and how the workflow moves the video from one step to the next. Add this node also. First, click on Expression, and then click the arrow icon. Now add the FFmpeg command. Do not let the length of this command scare you. The logic is much simpler than it looks. FFmpeg receives the file we just saved. It re-encodes the video using H.264. We use a CRF value of 28 to reduce the file size. The audio is encoded using AAC. And then FFmpeg creates a second file. The original file begins with input, and the processed file begins with output. Everything else keeps the same unique IDs, so we can always tell which input belongs to which output. One important point. This command is compressing the video. It is not resizing the resolution. The file becomes smaller because we reduce the amount of video data used to represent each second. Now, execute the node. FFmpeg starts processing the video. Your CPU usage may jump quite high during this step. That is normal because video encoding is heavy work. When the process finishes, look for exit code is 0 that tells us FFmpeg finished successfully. You may also see a large amount of text under standard error. Do not immediately assume that means something failed. FFmpeg normally prints progress and encoding information there. We'll pin this node as well. Add another read-write files from disk node, but this time we choose Read File from Disk. Earlier, We moved the original video from N8N to disk. Now we are doing the opposite. We are taking the FFmpeg output file from disk and loading it back into N8N. Use the same output file name pattern we created in the FFmpeg command. Execute the node. Now the processed video appears inside N8N as binary data. We can see that it is an MP4 file. We can see the output file name, and in my example, the size is about 304 kilobytes. I can even preview the video directly inside N8N. So we know the compression worked before we send anything back to Telegram. Now add another Telegram node. This time choose Send Video. Remember the chat ID we received from the very first node? That expression simply means send the finished video back to the same chat that started this workflow. Enable binary file as the binary property, and if you want, add a simple caption. For example, video processed successfully with N8N FFmpeg. Now execute the node. And there it is. The processed video has returned to Telegram automatically. No manual download, no video editor, no uploading the file to another website. The user sends one video and the automation handles everything in between. And this is only the foundation. Right now, our bot has one job: receive a video and return a compressed version. But once this basic pipeline exists, things become much more interesting. We can make the user choose what they want to do with the video, convert MP4 to MP3, add a watermark, resize a video for vertical, square, or widescreen platforms, generate a thumbnail, remove the audio, split a long video into smaller parts, or return information such as duration, resolution, and file size. And later in this series, I want to build one feature that is especially useful. If you are following this N8N and FFmpeg series, subscribe so you do not miss the next build. Thanks for watching, and I will see you in the next one.